Hi, welcome in this tutorial. Today, we are going to explore the extraction module. This module is part of the design layer and will help you convert multimodal data into tabular data that can enter the learning module. It is divided into 4 parts. The first part, MEDimage, is still in development and not available yet. The second part is text extraction. It is made to extract data from text contained in CSV tables. Then, you have the time series extraction part, which allows you to extract data from time series also contained in CSV tables. Finally, you have the image extraction page that allows you to extract data from JPG images. So, let's start with the extraction image page. In this page, the first step is to import your data. Then you will be able to choose your extraction type with several options. While all the required options aren't completed, a warning is displayed and you will not be able to click on the extraction button. Let's import our data. For this tutorial, I choose a subset of patients from the Mimic4 database. The patients I selected are the ones whose CSV data is available without credentials on the Mimic4 demo data in FissionNet that not include their notes and images. Here, your data must be contained in folders, each folder corresponding to a patient. Each patient folder may contain subfolders, at the condition that all the patient's folders respect the same hierarchy through the JPG images. If everything goes well, you should see a success message, indicating that your data have been imported. The second step is to select your extraction type. For now, only the DenseNet extraction type is available, but you still choose some options using it. Let's precise that this model is made for chest X-ray only. Using it with other data types will give you useless results. One of the options is that you are able to choose the model weights. You have several options, all come from the TorchRayVision Python library. Let's keep the default weights. Then you will be able to choose whether you want your generated embeddings to be dense features, predictions, or both. Here the predictions are a list of chest pathologies that you can find on the TorchRayVision documentation. The next step is to enter informations depending if you want your generated data to be compatible with the MEDprofiles process. If so, you must load a CSV associating your image's file names with dates. Having dates is necessary in the MEDprofiles module. You also need to provide which folder level contains patient identifiers. For example, my first folder level contains patient's identifiers, and my second folder level, which are folders in the patient's folders, are study identifiers. So I select one as patient identifier level. Then, may check the info to parse your patient's identifiers as integers. That is useful in our case because in all other CSV files that we have, the identifiers are integers, which is not the case of folder names. Here, the option will parse folder names to keep only integers contained in it. Finally, you may indicate which columns in your CSV file corresponds to file names and dates. Here is an example of what the required CSV file looks like. Then, you will be able to choose the column prefix for your generated embeddings. This prefix will be used later in the MEDprofiles process. Finally, you will be able to choose under which name you want to save your generated CSV file. Let's extract our data. Once the data have been extracted, a message will appear on the bottom of the page, indicating where it have been saved. You will be able to see your generated CSV file directly in the extraction page. All of the extraction pages will save your data under the folder extracted features in the data folder. Let's continue our tutorial with the extraction time series page. For this one, I took the chart event CSV file from the Mimic4 demo database on FissionNet, and I made some manipulation on it in order to keep only some measured elements to avoid the data to be too large and the application to run slow. The measured elements I kept are the ones considered in the HIAM study, and you can find them on their GitHub repository. The next step is to select your extraction type and options. While all the necessary informations haven't been entered, a warning will be displayed and you will not be able to proceed to extraction. For now, you can only proceed to extraction with the tsfresh Python library. Here again, you have several options that you may choose to extract your data. You have 3 options for features generation. You can generate your embeddings by admission, meaning that your result dataset will contain one row by patient admissions, so one or multiple rows by patients. You can also generate your embeddings by patients, and then your result dataset will contain one row by patient. The third option is by hour range. With this option, the embeddings will be generated every specified time interval. For each patient, your result dataset will contain one row every hour range of the patient's stay. Like on the other extraction types, you have the option to make your result compatible with the MEDprofiles process. Setting this option on may ask you more information than a basic extraction and may render results with more, less, or different columns. Depending on the chosen option for features computation, you will have to enter certain informations on your dataset. The admission option is the one that asks for the most information. You will have to enter the patient identifier, the admission identifier, the admission time, the measured item identifier, the measurement date time, and value. The patient computation option will ask for less information. Here you can see that we ask a time column and a measurement date time or weights. These may be the same columns. The time column is only here in order to associate a date to each row data during the MEDprofiles process, while the measurement date time or weights are used for embeddings computation by tsfresh. The last option is computation by hour range. This is the one I am going to use for this tutorial. I am able to choose the hour range I want, but I decided to keep the default one, which is 24 hours. Here, as for the patient computation option, you will have to enter a time column and a measurement date time or weight. Here the time column isn't just for the MEDprofiles process, it is also used to split the data by the specified hour range. So, I enter all the required informations, and then you can see that the warning indicating that I must select convenient options for the extraction disappeared. Then you will have to choose the type of features you want to generate: minimal, efficient, or comprehensive. These 3 options are detailed in our GitBook and in the tsfresh documentation. You just have to know that efficient and comprehensive methods will generate much more embeddings than minimal. Then, as for all the extraction types, you will be able to choose a column prefix and a name for your generated CSV file. Let's extract our data. Once your data have been extracted, you will be able to display your dataset in the extraction page, except if you choose efficient or comprehensive option that give results too big to be displayed in the app. A message will appear indicating that your CSV result file have been saved. Here you can see the result of a computation by hour range, where every patient have embeddings for every hour range interval of his stay. As for all the extraction types, the result dataset is saved under the Extracted Features folder. Let's continue with the extraction text page. Here, as for images, the dataset is Mimic4 data, filtered by the subset of patients given in the Mimic4 demo database. If you want to access these notes data, you have no choice to have access to the full Mimic4 database. As for other extraction pages, only one type of extraction is available. It is BioBERT, a pre-trained biomedical language representation model for biomedical text mining. Here, you can see a warning indicating that you must have downloaded the model in your data folder in order to proceed to extraction. Let's do this. All the required informations to download the model are described in our GitBook. Once your model have been downloaded, refresh your workspace, and the warning should disappear. As for the time series extraction page, you have several options for feature computation. Like the other extraction pages, you may set your result dataset compatible with the MEDprofiles process. The main and default option is to compute features by notes. We provided the other options in order to study the mimic data in a HIAM way, but we recommend you to use computation by notes. The 3 options mimic HIAM specific works exactly like the ones in the time series extraction page, so I will not detail them. Then, like for time series, I indicate the required columns in the fields. Here the time column for computation by notes is only asked for the MEDprofiles process. Here again, I may choose a column name prefix and my CSV file name. Let's extract our data. Once the extraction is done, a message will appear indicating that your CSV file has been saved, and you will be able to display your result dataset in the extraction page. As for the other extraction types, your results will be saved under the Extracted Features folder in your Data folder. Well, we have seen how to use the extraction module. Don't hesitate to comment if you have questions. The next video will be about the MED Profiles process, where you will be able to see and manipulate our data. See you there.